180 pounds. That's my weight. What's yours? Did you know that in addition to weight, you and I have mass? In fact, weight is a measure of mass in relation to the pull of gravity. And mass is the amount of matter contained in something. So, less weight means less mass. Mass remains constant wherever it is, but weight varies from place to place in the universe depending on gravitational pull. Take the moon, for instance. Here on the moon, I'm the same physical size as I was on Earth. In other words, I have the very same mass. But up here, I only weigh about 30 pounds. And that's because the gravitational pull of the moon is less than that on Earth. But suppose I was on another planet. Out here on this very large planet with a very dense atmosphere, I'm still the same physical size as I was on the moon and Earth. But out here I weigh, good grief, 400 pounds. Get me back to Earth. Whoa, that's better. Here on Earth, I'm back to 180 pounds, and I still have the same mass. And that's what we're going to explore today, weighing mass in the metric system. The most commonly used units for measuring mass in the metric system are the milligram, the gram, which is the basic unit, and the kilogram. A gram is a mass of 1 cubic centimeter of distilled water at 4 degrees Celsius. In other words, if you have a cube like this one that is 1 centimeter wide, 1 centimeter high, and 1 centimeter long, you have a cubic centimeter, or the mass of 1 gram. This is a very small amount. The abbreviation of gram is G. The other two most commonly used units of mass are the milligram, which is smaller than a gram and abbreviated as mg, and the kilogram, which is larger than a gram and is abbreviated as kg. It takes 1,000 milligrams to equal 1 gram. That means that a milligram is 1/1000th of a gram. So as you can see, a milligram is very tiny. Also, it takes 1,000 grams to equal 1 kilogram. In other words, the mass of 1 kilogram is 1,000 times greater than 1 gram. Let's look at it another way. The milligram, the smallest unit, is the same as 1/1000th, written as a fraction, or decimal 001, 1,000th of a gram when written as a decimal. Imagine that. Now that is a very small amount of mass. To help you imagine how tiny in mass a milligram is, look at this paperclip, which is 3 centimeters long and has a mass of 1 gram. If I were to divide it into 1,000 equal pieces, each piece would have a mass of 1 milligram. Actually, the only thing I can think of that would have an approximate equal mass would be this small piece of cotton. Chemists and medical researchers often mix ingredients requiring a specific number of milligrams. And remember, it takes 1,000 of these milligrams to equal 1 gram. Let's look at another example of measuring mass using metric measurement. Remember the cube that we saw earlier? Well, imagine 1,000 of these stacked together. In other words, we would have 1 decimeter long, 10 of them, wide, 10 high, and 10 deep. Imagine them all filling this cube. That would be 1,000 of them, because 10 times 10 times 10 is 1,000. So, 1,000 grams equals 1 kilogram. Things whose mass would be determined in kilograms are a kitten, a math book, a boot, and 9 sticks of butter. Now I'm going to show you some objects, and you tell me the most appropriate metric unit of measure in which to determine their mass. And your choices are the milligram, the gram, or the kilogram. And remember, 1,000 milligrams is a gram, and 1,000 grams is a kilogram. When I show you an object, you choose the most appropriate unit of measure to use in determining its mass, and write the abbreviation for that unit on a piece of paper. And you'll have 3 seconds to write your answer before the answer is shown. Keep track of how many you get correct. Are you ready? Okay, here we go. Number 1, a computer. Would you determine the mass of a computer using A, milligrams, B, grams, or C, kilograms? And the answer is C, kilograms. A computer would have a mass determined in kilograms. Number 2, a candy bar. Milligrams, grams, or kilograms? And the answer is B, grams. The mass of a candy bar would be determined in grams. Number 3, a briefcase. The answer is C, kilograms. The mass of a briefcase would be determined in kilograms. Number 4, a stamp. The answer is A, milligrams. The mass of a stamp would be determined in milligrams. Number 5, a handheld calculator. And the answer is, once again, B, grams. The mass of a handheld calculator would be determined in grams. Number 6, 5 blades of grass. And the answer is a milligram, A. The mass of 5 blades of grass would be determined in milligrams. Number 7, a spool of thread. And the answer is also B, grams. The mass of a spool of thread would be determined in grams. Number 8, a grain of rice. A, milligrams. The mass of a grain of rice would be determined in milligrams. And finally, a dictionary. And the answer is C, kilograms. Again, the mass of a dictionary would be determined in kilograms. Okay, how did you do? How many did you get correct? Great. And for those of you who didn't do so well, stay with it. Practice on your own. You'll get it. As we learned before, when changing from a smaller unit of measurement to a larger one, we divide. And when changing from a larger unit to a smaller one, we multiply. Same thing applies in determining the mass of things in the metric system. Since each unit of mass that we learned about today is either 1,000 times larger or 1,000 times smaller than the next, we either multiply by 1,000 or we divide by 1,000. So to change from kilograms, a larger unit, to grams, the next smaller unit, we multiply by 1,000. For instance, to change 3 3/10 kilograms to grams, it would be necessary to multiply, since we are changing from a larger unit to a smaller unit. And to do that, we need to move the decimal 3 places to the right. Well, you're saying, well, we can only move it 1. So let's do that. 3, 3. Now, to move it 2 more places, it's necessary to add 2 zeros. So we began here, we moved it once, twice, 3 times. So 3 3/10 kilograms is equivalent to 3,300 grams. Now let's reverse the process and move from a smaller unit, grams, to a larger unit, kilograms. So therefore it's necessary to divide instead of multiply. For instance, let's begin with 4,000 grams. To change that to kilograms, it's necessary to divide. So all I need to do is move the decimal 3 places to the left. And remember, when the decimal is not shown, it's always at the end of the problem. So I will move it 1, 2, 3 places. So 4,000 grams is equivalent to 4 kilograms. Let's try one more. Let's try 11,400 grams and change that to kilograms. Again, remember, we're going from a smaller unit to a larger, so therefore it's necessary to divide. Now, again, the decimal's at the end of the problem, so to move it 3 places to the left, 1, 2, 3, it ends up there. So 11 4/10 kilograms is equivalent to 11,400 grams. Now let's use what we've learned in a real-world problem. Suppose a candy maker orders a sugar substitute to use to create a low-calorie candy bar. But the candy maker can only order the sugar substitute in kilogram containers. But each candy bar only needs 500 milligrams of the sugar substitute. So how many candy bars can the candy maker create with a kilogram of sugar substitute? To solve a problem like this, we need to find the number of milligrams that are in a kilogram. And there are 1,000 milligrams in 1 gram and 1,000 grams in 1 kilogram. So to find the number of milligrams in a kilogram, it's simply necessary to multiply 1,000 times 1,000. Here's the original 1,000 we start with. And to multiply that by 1,000, we move the decimal 3 places to the right. So therefore I will add 3 more zeros. And that means there are 1 million milligrams in 1 kilogram. Now to finish solving the candy maker's problem, we divide 1 million, the number of milligrams in a kilogram, by 500, the number of milligrams needed for each candy bar. 500 divides into the first 4 digits evenly 2 times. So all I have to do is add 3 more zeros. That means that out of 1 kilogram of sugar substitute, the candy maker can make 2,000 candy bars. The next time you buy a candy bar, read the label and see the various quantities listed in grams or milligrams. I hope you enjoyed learning the differences between the weight and mass and how to find the mass of things using the metric system. Until next time, this is Miles McLeader. See you later.